Hey guys, Mr. Harper Smith here. So the last couple of days we've been learning about z-scores, t-scores, how to calculate them, how to use the tables. And to be honest, the tables can be a little confusing sometimes. Even once you've practiced for a while, they can be quite confusing. Or same thing with the z-tables. You've been using them for a while and you can still, you're trying to come over and you jump down a row accidentally and then you end up looking it up wrong. It can be kind of tricky. So today what we're doing is we are going to figure out how to do this all with a calculator. So you just plug it into a calculator and it gives you the answer. So here, instead of having some t value that's between two places and then trying to figure out what the p value is based off some t value that isn't quite there, we're just going to do it the nice way with the calculator. All right. So let's start with z-tests. So remember, z-tests, we use proportions. T-tests, we use averages. So I'm going to pull up my calculator. Bloop. And this is if you're using a TI-nSpire. If you're using a TI-84, I've got another video already done up with how to use a TI-83 or a TI-84. So when we're doing this, we go to Menu, we go down to Statistics, and Stat Tests. If you need to pause to do that, do it. Now, please have your calculator out and doing these with me. Okay. Now, a lot of people are going to make this mistake and just go straight for z-test. And it's going to pull this up and then you're going to be confused because it's asking for average and standard deviation and the sample average and how many samples you had. But you don't have an average because these are proportions. You don't have an average with proportions. So you obviously did something wrong. So you go back and you try again. So you go to Menu, 6, 7, 5. I'm sorry, I should have done that a little bit slower. So we go to Menu, 6, 7. You go through and look at all these. You got t-test, 2 sample z-test, 2 sample t-tests, 1 proportion z-test. Now guys, we're working with proportions. Proportions are different from averages. You can use a z-test for an average. You can. We prefer t-tests, but you can use a z-test. However, with proportions, you have to use a z-test. All right, so the only proportion, 1 proportion z-test is option number 5 for me, 1 prop z-test. I'm just gonna pull this up. Now let's me put in my proportion, 0.4. N is how many samples I had. X is how many successes I had. I had 15 successes across 43 trials. Then finally, it wants us to select the alternative hypothesis. So what is the alternative hypothesis in this case? Well, it's either a 2-tail test, which would be not equal to. It looks like we want a 1-tail test, which means it's either going to be our proportion is less than the null hypothesis or it's more than the null hypothesis. Okay. Well, if we do 15 divided by 43, that gives us 34%. Is 34% more than 40% or less than 40%? It's less than. So here, our proportion is less than the null hypothesis. So that's going to be our answer. I hit enter. It's going to give me a p-value of 0.246. If I have a p-value of 0.246, do I keep or reject my null hypothesis? Well, we don't have an alpha, but you'd have to have a pretty big alpha to get rid of the null hypothesis with a p-value that large. So in this case, we don't have enough information to really reject the null hypothesis, okay? All right, let's scroll down. Let's try another one. Here we go. Go Menu, 6, so statistics, stat tests, we're doing 1 proportion test. We're going to do 0.2. We're going to do successes. We've got 25 successes. I don't know who you are. And our number of trials, we had 150 trials. Finally, we need to determine, are we more or less than? It's a 1-tail test, so it's not going to be equal to. So our proportion was either more than or it was less than. Well, 25 divided by 150, I think is like 15% or something like that. So we are less than. Okay, our proportion was less than the null hypothesis. Hit enter. Let's look at what our p-value is. So you can see it shows us the z value. It also shows us the p-value. It does both. So it goes through, calculates z, then runs it through the table to get us p. How much cooler could that be? So we get a p-value of 15%. All right, 0.15. Now, if our alpha was 0.05, would we keep or reject? In this case, we would keep the null hypothesis because we are not less than 0.05. All right, let's try one last one. Pause the video and give it a quick try. All right, you should have paused the video. You should have the answer. I'm just going to make sure that you've got it. So we've got 6, 7, 5. We've got 80%. X is 60. N is 84. Now, here's where some of you might have got a little confused. It's a two-tail test. Since it's a two-tail test, it could go either way. So we just care that it does not equal the null hypothesis. I get a p-value of 0.049. Now, depending on what your alpha is, you might reject the null hypothesis at this point. Yay, we finally got to one like that. Cool, cool. Let's look at t-tests. Let's go over how to do a t-test on a calculator. It's very similar. You go to menu, you go to statistics, you go to stat tests, but since we're doing a t-test, you just click on t-test, so number 2. Boop. And instead of data, we want to do the statistics, okay? That's something I probably didn't mention well enough earlier. But if you click on data, it's going to ask you to put in all of the data that you collected from all of your samples. We don't want that. We just want to put in the statistics. So our null hypothesis was 30. Our sample average was 34. Standard deviation of our sample is 3. N, so the number of samples we collected was 28. And it's a two-tail test. If it's a two-tail test, is it going to be not equal to, less than, or greater than? Two tails could go either way, so it's going to be not equal to. And we get a p, let's see here, we go through, we get a t-value of 7. So 7 standard deviations. And a p-value of 1.38. Well, that's not 1.38. You see the e to the -7? So there are 6 zeros in front of the 1. So 0.0000001. Basically, this is really small. The chances of this happening, the chances of getting something that's 7 standard deviations away from the average is extremely unlikely, extremely unlikely. In this case, we would reject the null hypothesis. Let's try another one. Okay, I'll do this one. You guys do the next one on your own. Here we go. We go to menu. We go down to statistics, stat tests, number 2. We want to make sure that we are on statistics, right? We are entering in the statistics, okay? Entering my data. I've got a population average of 60, sample average of 52. Standard deviation of the sample is 5. N, so the number of samples I took was 8. Now this says that it's a one-tail test. Is 52 less than 60 or is it more than 60? It's less than. So we want U to be less than the null hypothesis. And I click enter. We get a t-value of 4.5, a p-value of 0.001. If you have a p-value of 0.001, you're more than likely rejecting your null hypothesis. I really doubt that you're going to keep the null hypothesis in that case. So, awesome. Was that a lot easier than going through and calculating it all by hand and then using the table to try to find the answer? Oh yeah, a million times easier. Last one. You give it a quick try. Pause the video if you need to. All right, you should have the answer by now. You should have paused the video. We go to 6, 7, 2. Make sure that we are on statistics. If we're not on statistics, then this doesn't work. We put in the null hypothesis average, 130. 125 was our sample average with a sample standard deviation of 6 and a sample size of 180. Okay, now this is assuming that we are randomly sampling. Anybody could be picked. It's a one-tail test. 125 is less than 30, so we'll be less than. Okay. Some of you might not have changed that. Hit enter. And we get a p-value of 0. Basically, that's not going to happen. Think about it. If you go off and get 180 samples and you get an average, if you have 180 samples, you're going to be pretty close to what the average should be. Okay. If we're talking about height, if you go out and get the average of 180 random adults in the United States, completely random. It's not just people that are running into the store or whatever, it's completely random. You're gonna have a pretty good idea of what the average is for the United States as far as height goes. Well, if the claim is that the height is actually 5 inches taller, that's almost half a foot. Something is obviously wrong, okay? Now in the US, the average height is 5 feet, 5 inches, 65 inches, so 65. This is saying that's 11.18 standard deviations above the mean. So 11.18 times, and the standard deviation for height is 3.5. So it's just to put this into perspective, if someone really was 11.18 standard deviations above the average, they would be almost 9 feet tall. They'd be 8 feet 8 inches tall. That is insane, okay? I don't know if I've ever met anybody even over 7 feet tall, let alone 8.5, almost 9 feet tall. All right, so here, that's just to put into perspective. It's not going to happen. It's not likely. So we definitely reject the null hypothesis. All right, your turn.